This is an example of exponential regression, and we're going to use the Desmos graphing calculator in order to get our exponential regression equation and graph. In this example, we're told that the number of new cryptocurrencies Y changes day to day, but the approximate number of such currencies in circulation for selected years is given in the table. Year 0 represents 2015. So that's an important piece of information that tells us where we're starting. So, for example, the year 3 would represent 2018, since 0 is representing 2015. So that lets us understand better what this data is telling us. So what we want to do is we want to graph the data on a graphing device. That means get a scatter plot and determine, based on the shape of the graph, which function type would be the best model for this data: linear, exponential, or logarithmic. So I'm going to pull up the Desmos graphing calculator, desmos.com/calculator. And I'm going to go ahead and hit the plus button in the upper left, select table, and I'll put all of my X values in the first column. Okay, and then in the Y column, in the second column, I'll put all of the Y values, or number of cryptocurrencies in this case. We have 491, 551, 617, 1,334, 2,995, and 5,392. So I've got all my data in there. Double check to make sure everything's typed in correctly. Okay, then go to the second box and well, actually, we're not getting our regression equation yet, so I'll save that for just a minute. So what I want to do is I want to get the scatter plot. So I have to go up to this wrench in the upper right corner, and I'm going to adjust the window. Now notice on the table, my lowest X value is 0 and my highest X value is 5. So for my window, for X, I might go from 0 to 6. And I'll go ahead and do a step of 1. Now my lowest Y value is 491, and my highest Y value is 5,392. So I might do something like 0 to 6,000 with a step of 1,000. So I'm adjusting my table, I'm adjusting my window based on the table. I want to be lower than the lowest X value, higher than the highest X value. Or if you're starting at 0, just start at 0 for the X. For the Y, I want to be lower than the lowest Y value and higher than the highest Y value. So there's my scatter plot. And what I want to do is select the correct option in Alex. And then I want to look at the shape of my scatter plot. Now this is starting out kind of a slow, almost horizontal line, and then shooting up very quickly as X gets larger. So that looks like an exponential to me. So over here, I would go ahead and answer that the exponential would be the best fit for that graph. So it has that shape that shoots up very quickly. Now we're told use a graphing utility to find a model of the form f of x equals a times b to the x. So in Desmos, I'm going to go to the second box here, and I'll type in y1. Notice that the title of my y column is y1. So I do y1. I want to do a tilde. So I do shift and then the key that's just to the left of the number 1 key on your keyboard. So y1 tilde, and then I'll do a times b to the x1 because my x column is labeled x1. So I have y1 tilde ab to the x1. Now this next point is really important. In order to get the correct exponential regression model, I have to click this box, this checkbox next to log mode. So I'm going to check the box next to log mode, and that will give me the correct parameters for my exponential equation. Okay, so I have y1 equals a times b to the x1, and I see that a is 346 and b is 1.664. They say round a to the nearest whole unit and b to 3 decimal places. So I'll have f of x equals 346 times 1.664 to the x power. All right, so that's my first answer. That's my a times b to the x. Then they go on to say, write f of x as an exponential function in the form f of x equals a times e to the bx. So now I have to use my knowledge of exponentials and logarithms. So since e to the x and natural log of x are inverses, or inverse functions, I could say, we know that if we compose them, like if we did e to the natural log of x, so I'm plugging in natural log of x as the exponent, that's going to equal x, because when you compose two inverse functions, you get the input, or you just get x is another way to think about it. So what I'm going to do is I'm going to do e to the natural log of 1.664 is equal to 1.664. All right, so what I need to do is I need to go ahead and figure out what natural log of 1.664 is. To do that, I can use the Desmos scientific calculator. And I'll go ahead and put in natural log. So I go to function, natural log of 1.664. And I get 0.509. So natural log of 1.664 is 0.509. So this will give me e to the 0.509, e to the, let's say 0.509 is equal to 1.664. So what I'll do is I will replace the 1.664 with e to the 0.509. And so I'll get f of x equals 346 e to the 0.509x. The x still has to be there. And the 346 still has to be there. But I replaced the 1.664 with e to the 0.509. So this value, the 0.509, is always going to be the natural log of the original b value. And so we have two equivalent exponential functions, one in the form a times b to the x, and the other in the form a times e to the bx. Now we're asked to use a graphing utility to graph the function and the data points. That happened automatically in the Desmos graphing calculator when we did the scatter plot and adjusted our window and did our y1 equals a times b to the x. So this would just be a matter of matching up the graph and scatter plot to the correct option in your homework system. Last, we're told use either model to approximate the number of cryptocurrencies in year 6. Round to the nearest whole unit. So let me rewrite our function here. We had f of x equals 346 times 1.664 to the x. Okay, just double checking I wrote it down correctly. So f of 6 in year 6 is going to be 346 times 1.664 to the 6th power. And to calculate that, if you're using the Desmos calculators, go to your scientific calculator and you'll go ahead and put in 346, go to times 1.664, hit this a to the b key, and then put in a 6, and you should get your answer. So they say round to the nearest whole unit, so 7,345. And that's all there is to exponential regression. The hardest part is remembering that when you're changing from the a to the bx form to the form a e to the bx, that new b value is going to be the natural log of your original b value. Also, when you're doing the exponential regression in Desmos on the calculator, be sure that you're clicking that log mode button, otherwise your values will come out incorrectly.